So my talk today is an introduction to LLMs on Kubernetes, and just to better understand you as an audience, real quick, maybe you can raise your hand and keep your hand up if you have heard of ChatGPT. Awesome. Who's used ChatGPT? Okay, still almost everyone. Who's run an LLM locally? Awesome. Another question, who's heard of Kubernetes? I hope most of you as well. Who's operating Kubernetes? Still most of you. Awesome. So you're in the right room then. Because today I want to bring those two topics together. And why did I even look into this? So I read a lot of quotes, and one of them is by Eric Schmidt saying AI is the beginning of a new epoch of human civilization, a watershed moment. And there are lots more of them out there, and that kind of got me thinking, okay, what is this new technology that everybody's talking about? So I thought, okay, not too distant past, my situation was I knew Kubernetes, so I've heard about these large language models, and I felt pretty good about myself. But then I thought, okay, maybe I should learn how to run them myself. And fairly quickly, I was back in this place, and that felt way more comfortable to me because that's usually where you are. So I want to take you along the journey that I took to understand what a large language model is, to understand how it runs, operates, and then how to do all of that on Kubernetes. So let me introduce myself. My name is Alexander. I am the founder of QG. We are starting a new brand, DAX IT, that does managed services. This year, I have the privilege of being a CD Foundation, Continuous Delivery Foundation ambassador, and I've been using Linux pretty much all my life. So let's start off like everybody starts off. Let's do something locally real quick. So I used a tool called Ollama, and I pulled an open source large language model by running Ollama pool and then the name of the model. Then I said Ollama run, and I asked it a question. And that was a very, very simple and quick first touches with an LLM that if you have a laptop that has somewhat of a GPU, for instance, like a Mac, then this can all run locally pretty good. But what just happened? So let's talk about what a generative AI actually does and how does it work. So when you download something like I did with the Ollama pool, you get a pre-trained model. And then a pre-trained model comes with a system prompt. And then we add some input to it, another prompt. So for instance, tell me something interesting about Hamburg. Then the large language model responds to us by giving us an interesting fact, and we can ask it something else. And wait, is it a good place for cycling? So I refer to Hamburg by saying it, but the large language model still understood and was dereferenced it to Hamburg and still understood the context I was talking in. So how does it do that? So large language models work by generating one token or one word at a time. They use all of the context of the previous tokens as context for the next prediction. So the way it works is let me go back. They have the pre-trained model, they have the system prompt, and they have the question. So by using this information, they predict the next word that might most likely as a response. So it's going to be Hamburg. At that point, it repeats itself. So it takes the pre-trained model, it takes the system and the user prompt, and then Hamburg as the new input for the next iteration. And it keeps doing that until it feels like, okay, I kind of feel like I answered the question. And then when I add another system prompt, it does that all over again. So by doing that, it's a very iterative process, and it's also highly parallelizable, which is why LLMs are really good on GPUs. They can, they can do the operations highly in parallel, which is why a GPU is more suitable for running it. And yeah, think that's a fact. Okay, so LLMs have different use cases and different limitations. So the most known use case right now is chat use case, because LLMs are really interesting to interact in a chat mode, because that's very natural to us. But there are also limitations. Like, for instance, if you throw a bunch of numbers at it, it will have a really hard time to understand all of those numbers and make sense of it. There's another field of AI or machine learning that's way more suited to work with large number sets. But everything that's regarded natural text processing, long text contextualization, those are use cases you can use LLMs for. And the most well-known GPT model right now is OpenAI's GPT-4. But there's also other models that are open source, like, for instance, by Meta, there's a Llama 3 or 3.1 model that they open sourced. But what do I mean by open source? Because a model comes with different components. Only one of them is, or a couple of them is what I download when I say Llama pull. Like, most of the most interesting part is actually the data set that goes into the model. And for instance, Meta has not open sourced that data set, which is like terabytes of data. But there are other models, and I'll add a link to a model registry at the end where you can also find data sets if you want to work on a model yourself. But models are usually measured in the number of parameters they have. That's kind of like, you can think of it as the amount of knowledge it has, the amount of data it was trained with. So, for instance, with the Llama 3.1 model, you get 3 different sizes. You get an 8 billion token size, or 8 billion parameters, 70 billion, or 405 billion. And each model, even in different sizes, has different use cases. So, for instance, the 8B model is very good at summarizing. So if I give it a text and ask it to summarize that text, it's really good at it, because it can understand the text, it can summarize that text, but it's really hard to, it's struggling with more open questions. Like the question I gave it, tell me an interesting fact about Hamburg, that's a more open question, and a model like an 8B model has a really hard time answering that. And it gets it wrong many times because it just does not have the information. A model like 70B, on the other hand, has way more context it can work with. So it's well suited to answer open questions. And then the 405B model is actually very large. I think it has around 200 gigabytes of sheer data it works with. So that's something that's really hard to actually run on a GPU. The 70B has around 40 gigs, and the 8B has about 5 gigs. So, and you need that amount of RAM ideally available for the GPU to actually load it all into the GPU and be more efficient. There are scenarios where half of it is in the GPU VRAM and half of it is in the CPU RAM, but that immediately will affect the performance. But so why did I slide Ollama in there? So I'm talking about large language models. I used Ollama. What is the Ollama for? So the LLM, among other things, consists of the parameters, and that's the file I downloaded, or one of the files I downloaded. And it's billions of weights and biases is what it's called. But that's just a big old file. I cannot execute that file by itself. I kind of need a runtime to be able to actually load it and interact with it. And there are different inference runtimes that you can use, and that basically turns the large language model I downloaded into more accessible data. And for example, there are 2 inference runtimes which are quite well known. Those are, for instance, Ollama and vLLM. And after I did all of that research and understood, okay, I can run it locally, and I can, and I understand kind of what an LLM is. So then I thought, okay, how do I do this on Kubernetes? And before we jump into that, kind of like, why would you even do it on Kubernetes? Well, my idea was, I already have Kubernetes in-house, so I can have that large language model also on the same platform, which is kind of nice. I can use Kubernetes features like scalability and high availability for making sure that my models are running, that they perform. I can scale up if I want to, in case I have the GPUs. And it also does the load balancing for me. So there are a lot of reasons why I liked putting a large language model on Kubernetes. On the other hand, those are really resource-intensive tasks, and GPUs are quite expensive. So I really need to make sure that I make the best use of them. And it's also really important to know that a cold start really takes some time. So the video I showed you where I ran Olama locally, I executed those steps twice right after each other. That's why it took nearly no time. The download, obviously, depending on your internet connection, takes some time, and then the running takes about, depending again on the model size, 30 seconds to start. So you really need to make sure that you account for that time if you run it on Kubernetes. And then there are other things you need to consider, like scheduling. Requests in an inference engine are usually processed sequentially. That means if I send the first question and then somebody else sends the second question, it's going to answer the second question after it's processed the first question. And that's a thing to remember. So if you only have one GPU, it will be basically sequentialized. There are different ways of where you can split it, GPU into more partitions or more time slicing to have it operate multiple tasks, but that's all out of the scope for the talk today. But I'll give you some pointers if you were interested in learning more about that. The other thing you need to think about is utilization. So basically, the GPU does nothing. Well, it loads the model, then it does nothing until you ask it a question. So the load model is kind of like 0, 100, 0, 100. Every time you ask a question, it's at full throttle, and then after it's done, it's basically idle again. So you need to think about how can I, schedule it in a way that my GPU is utilized quite often, because if you try to scale to 0, then you have that initial cold boot time to consider. The other thing is you need to know kind of what GPU, what model, and what kind of node do I need for operating my LLM model. So for instance, I'll give you an example later, but you need to kind of try out a couple of models to see if you are in the cloud. Then you can play with different models, see how they perform, because every single different, for instance, AWS EC2 instance has a different GPU attached to it, and that will perform way differently. So there is some trial and error involved here as well. And then the other thing is cost optimization. You need to weigh the amount of money you spend on a GPU, either for buying it or running it on a cloud, versus the time it takes to actually start, provision that GPU, and making it available for the first request. So especially in the beginning, that's quite a hard thing to do, because you don't have that many users maybe on it, there's not that many requests, so it's idling most of the time, so you're wasting money. But then when somebody comes around and you really want to convince somebody at your company to, hey, this is a good thing, and then they got to wait a minute for the first response, they will close that window way before they ever saw the response. So that's a kind of trade-off you need to think about. And the last thing I'm going to go into is so-called Kubernetes device plugins, because accessing a GPU actually needs drivers in most cases, and there's a Kubernetes extension called device plugins that allow a pod or a container to actually access the GPU. And there are device plugins for different vendors, and you need to make sure that your host operating system, so the container operating, or the operating system that runs the containers, has that device plugin installed in a way that it tells the kubelet, hey, listen, there is a device here you could utilize if you so choose. So my colleague always tells me 100% of demos are risky, but I'll say let's try them anyways. I do have backups, so let's see how it goes. Actually, give me a sec. I did have problems this morning with the back. I'm actually going to go with the backups just to make sure. So I said you need a GPU, you need a device plugin, and you need a daemon set that kind of enables the device plugin towards the Kubernetes. I really recommend to you also put a taint on the nodes that the GPU is attached to, because you want that nodes to only run processes that actually require that GPU, because you don't want to fill that node up with something else and then be in a situation where your actual LLM workload does not fit onto that node anymore. Another thing you really need to think about is an LLM, and if you choose to use Ollama, they do provide a container image out of the box that you can use. The best way to store your large language model is actually on a read-only many kind of volume, and not every storage provider provides that. Why am I saying that? Because actually, Ollama, and especially the LLM, is stateless. So you can have multiple instances access the same model file. And read-only many is just the best idea to do that. The deployment itself is quite simple, quite straightforward. I'll show you in the next slide what you really need to look into. And then you need a service to open that port towards the Kubernetes infrastructure. And then you need a front end, and that can be curl, that can be, for instance, Open Web UI, which is a project that's used to be called Ollama Web UI, but then they decided to open themselves more up. And that basically is a standard web front end, which needs a deployment, a service, and ingress. Nothing very special about here. Yeah, database and stuff like that, but it's basically a regular application. So let's look at the deployment. And the really important part here, I shortened it, obviously. The really important part here is that you request a GPU, and you do that by adding nvidia.com/GPU1 to your request block next to your CPU and your memory block. And usually that would do nothing, but because we have that device plugin, the device plugin specifically looks for something like this, and that's where the connection happens. And if you have something that's not NVIDIA, I'm not really into deep with AMD, but they do have a similar setup, then you need a different request in order to access an AMD GPU. And obviously add a toleration. Like I said, you don't want anything running on your NVIDIA node that does not require that GPU power. So I said localhost, but you can obviously port forward into the cluster. Just go ahead and then ask it by curl, hey, listen, I want to add the model, or you specify the model, you specify the message, you say, hey, I'm the user, and I want to learn an interesting fact about Hamburg. And then something interesting happens here, because I said stream equals false. The APIs are designed to output actually each word or each token they generate. Like I said, the LLM works iteratively, and the API actually reflects that. So when you see on different websites that the answer is actually parsed word by word, that's not only for your pleasure, but it's also actually because the technology works that way. It gives you one word after the other, so why not output it one word after the other? Makes it feel more human-like too. But I can tell the API, please don't do that. I just want the whole answer. So for instance, if your integration, which might not be a chat application, you do not want the streaming content, then you can just do that. And I notice I'm short of time, so I'm just going to show you the response, and then I'm kind of done as well. So the answer is just going to be, hey, I'm your assistant, and that's the content I gave you. Questions?
Yes, you can use the Slido app if you're on YouTube and also in this room. So far, we don't have questions, but I have one.
Oh.
Where do you run your GPUs?
So we do run them on AWS. We are also trying to build a local cluster with local GPUs, but we're still working on that.
All right. Cost is definitely an issue with GPUs, I suppose.
Absolutely, the initial cost is quite high. And I added a QR code. Oh, it's gone now. I added a QR code. If you want to download the slides, they're going to be available in a couple of days.
All right.
I'll share it later. There it is. Thank you.
All right. First question. Oh, can we get Slido up? Did you also compare performance with other non-Llama models?
Yes, we did. So for your use case, you will want to try out a variety of large language models. I said Llama 3.1, which is a fairly general use model. But for instance, if you want to generate code, like as a code assistant, there are other models out there which are way more specified to a specific task, and then you want to try that. And as in performance, it kind of depends on the size and the GPU. So if you use a large model on a small GPU, that's usually the bigger performance impact you see than running the wrong model.
All right. Thank you very much, Alexander. Please
Awesome.
give him a hand.
Thank you very much.